So jaundice is a condition where we have yellow discoloration of the skin, the conjunctivae, and the mucous membranes. The thing that causes this yellow discoloration that we see in jaundice is actually the widespread tissue deposition of bilirubin, a pigmented metabolite. General increase in bilirubin will cause jaundice. But how does bilirubin increase? There are two ways. The way to increase bilirubin is either to increase its production or to decrease its hepatobiliary elimination. So either we increase the production or we decrease the elimination. The pathway of the bilirubin metabolism, in which blood that carries this bilirubin albumin complex enters the liver. The hepatocytes filter bilirubin inside the gallbladder and excreted via the common bile duct inside the duodenum. In the duodenum, it enters the small intestine, large intestine, and it simply gets excreted with feces. So in order to better understand jaundice, we need to understand in further detail bilirubin metabolism. So it all starts with red blood cells that are about to die after about 120 days. These red blood cells, when they're about to die, they get phagocyted by macrophages. So these big molecules right here, these big cells, sorry, macrophages, eat red blood cells, dissolve hemoglobin to globin and heme. So heme and globin. From these two, heme actually gets further metabolized and becomes what we call unconjugated bilirubin. So this is unconjugated bilirubin. Unconjugated bilirubin, which is produced by, again, the metabolism of heme from red blood cells, goes ahead and binds to albumin and is transported into the liver. At the liver, unconjugated bilirubin enters a hepatocyte. So let's say that this is, for example, a hepatocyte. Inside the hepatocytes, unconjugated bilirubin becomes conjugated. Conjugated bilirubin is actually lipid soluble, is excreted inside the bile ducts in the gallbladder. So conjugated bilirubin rests in the gallbladder as bile and is excreted in the intestines. We eat food with high fatty contents. So when we eat food with high fatty contents, bile is excreted from the gallbladder into the intestines. Now, unconjugated hyperbilirubinemia is, as the word suggests, right, hyper, so too much bilirubinemia, too much bile bilirubin in the blood that is unconjugated. So this means that either we have a problem right here where we have increased bilirubin production, have many red blood cells dying, for example by hemolysis or multiple blood transfusions, for example. So, or either by increased bilirubin production, so we have more bilirubin circulating in the blood, and this way we have jaundice. By a problem right here where we have decreased hepatocellular uptake of circulating unconjugated bilirubin, so it doesn't enter the hepatocytes, right? There's a problem in the hepatocytes. Usually drugs cause this. Drugs won't let the hepatocytes take up unconjugated bilirubin that's circulating. Finally, we may have a problem right here in the conjugation of bilirubin. So this process does not take place, usually caused by genetic disorders. We talked about unconjugated hyperbilirubinemia. Now let's talk about conjugated. So conjugated hyperbilirubinemia means that we have increased proportions of conjugated hyperbilirubin in the blood, conjugated bilirubin in the blood. Conjugated hyperbilirubinemia causes obstructive jaundice. Why is this? Because in order for conjugated bilirubin to increase in concentration, we need to have an obstruction. Be, for example, a bile duct obstruction, a pancreatic head cancer, something that obstructs the bile from being excreted. In general, we could say that jaundice may either be caused by intrahepatic causes or extrahepatic causes.